I did practice 2. The function f is defined by f of x equals 3x plus 2 all over 4x squared minus 1. X is all real numbers. X not equal to p, x not equal to q. A. Find the value of p and the value of q. Since this is a rational function, the domain is 4x squared minus 1 not equal to 0. Let's solve. Factor 2x plus 1 times 2x minus 1 not equal to 0. So x not equal to negative 1 over 2. X is not equal to 1 over 2. So p equals negative 1/2 and q equals 1/2. Or q equals negative 1/2, p equals 1/2. Let's go to B. Find an expression for f prime of x. F prime of x equals 3x plus 2 all over 4x squared minus 1 prime. We will use a quotient rule. U over v prime equals v squared as a denominator, u prime v minus u v prime. Denominator 4x squared minus 1 squared. Numerator 3x plus 2 prime times 4x squared minus 1 minus 3x plus 2 times 4x squared minus 1 prime equals denominator 4x squared minus 1 squared. 3x plus 2 prime is 3 times 4x squared minus 1 minus 3x plus 2 times 4x squared minus 1 prime is 8x. Simplify. Distributive property 12x squared minus 3. We can count this as negative 8x times 3x plus 2. Still do the distributive property minus 24x squared minus 16x all over 4x squared minus 1 squared equals, combine like terms, negative 12x squared minus 16x minus 3 over 4x squared minus 1 squared. The graph of y equals f of x has exactly 1 point of inflection. Find the x-coordinate of the point of inflection. We need to put f of x into calculator. Open another document. Go to document. Insert. This time, put the problem. Go to 2. f1 of x. Then enter. Tab again. Shift minus d dx of use variable f1 of x. Enter. Tab again. Shift minus d dx of use variable f2 of x. Enter. Since we are looking for the point of inflection, go to tab, unselect this f2 of x, and f1 of x. We only need this second derivative function. We're looking for the x-intercept. It's not clear. You need to change the domain. Remember, if we only look for x-intercept, here is the window you need to set up. Menu, go to 4, enter. X minimum, X maximum. You can put a big one, -20, +20, 2. Y minimum, -0.1. Y maximum, +0.1. Y scale, 0.1. Enter. So this time, really clearly, you could see this is a x-intercept. Go to menu, 6, 0. You are given this -1.60 as a 3-sig fix. Sometimes, if your calculator cannot get this, normally we go to tab, put in 0, then enter. Go to menu again, 6, then go to 4, intersection. In this way, it's easier to get this x-intercept. Then control doc, we just add page, not add the problem. 1, 2.1, 2.2 means all the problems are connected to each other. So variables, 1, f1 of -1.60, enter. This is the coordinate of the point of inflection. First step, solve f double prime of x equals 0. X equals -1.60. Second step, f of -1.60 equals -0.303. So the coordinate of a point of inflection, -1.60, -0.303. B. Sketch the graph of y equals f of x for x greater than or equal to -3, less than or equal to 3. This gives you the clue about the window in your calculator, showing the value of any axis intercepts, the coordinates of local maximum, local minimum, and a point of inflections, giving the equations of any asymptotes. We already know the asymptote line x equals -1/2 and x equals 1/2. Point of inflection, -1.60, -0.303. Y-intercept, we can use a variable 1, then 0, enter. 0, -2 is a y-intercept. Control left arrow, go to page 2.1. We need to go to tab and select all the functions except the original function. Go to menu, use the given domain, -3, 3, 1. For the y minimum, -10, 10, 1. Just try. Enter. This is a pretty good graph. So we will figure out the maximum value, x-intercept. I also show you how to figure out y-intercept from this graph. Go to menu, 5, 1, graph trace, then put 0, enter. This is a y-intercept. Menu, 6, 0, negative 0.667 as the x-intercept. You can work out this x-intercept by hand, which is negative 2/3 from the given function. Menu again, go to 6, maximum. This is our maximum value. Let's check what's going on over here. So you need to change the window. We will change the y minimum into -2, maximum into 2. Scale is 1. So you could say there is a minimum point, and the concavity changes at that point of inflection. Go to menu, 6, 2. Figure out this minimum value. It's here. For this rational function, you can use calculator to get this x-intercept. You also can work this out by hand. You make 3x plus 2 equals 0, x equals -2/3 for the x-intercept. Since this is a rational function, you need to check the horizontal asymptote line. For horizontal asymptote line, we will use limits. Y equals limit x approaches infinity of 3x plus 2 over 4x squared minus 1 equals limit as x approaches infinity of we will use leading terms for numerator and denominator. So we have 3x over 4x squared reduce equals limit as x approaches infinity of 3 over 4x equals 0. So we do have a horizontal asymptote line y equals 0. Coordinate plane x, origin y. We are given this window. So you have to use the given window from -3 to 3, -2, -1, 1, 2. Use a ruler to draw this vertical asymptote line. Label x equals -1/2, x equals 1/2, y equals 0. Y-intercept. X-intercept is a -0.667. Local maximum. Local minimum. Point of inflection. label. Function g is defined by g of x equals 4x squared minus 1 over 3x plus 2. For x, it's all real numbers, and x is not equal to negative 2 over 3. Find the equations of all the asymptotes on the graph of y equals g of x. There is a vertical asymptote line, x equals negative 2 over 3. Then check the marks. 4 marks means we have other asymptotes. Check horizontal asymptote line, y equals limit as x approaches infinity of leading terms 4x squared over 3x. Reduce. You will get infinity, which means no horizontal asymptote line. You can check oblique asymptote line. For the oblique asymptote line, one more degree. Degree of numerator is 2. So there is an oblique asymptote line. We will use synthetic division to work this out. Or you can use long division. It's really up to you. I will show you both. So for the synthetic division, you have to take this 3 out. X plus 2 over 3 as a denominator, numerator 4x squared minus 1. Root in the corner, no missing power. So we have 4, 0, negative 1, negative 2 over 3 as a root. Drop down 4, multiply. Negative 2 over 3 times 4 is negative 8 over 3. Adding negative 8 over 3. Leading power is x squared, so here's x. Do not forget this 3 divided by 3. 4 over 3x minus 8 over 9. This is an oblique asymptote line. We can use long division to work out this oblique asymptote line. 4x squared plus 0x minus 1. 3x plus 2. First step, leading term divide. 4x squared over 3x equals 4 over 3x. 4 over 3x. Then do the multiplication. 2 times 4 over 3x is 8 over 3x. 3x times 4 over 3x is 4x squared. Then we need to do the subtraction. Change the sign. Positive, negative, negative. Then we add negative 8 over 3x. Bring down this minus 1. This time, leading term is this and this. Negative 8 over 3x divided by 3x equals negative 8 over 9. So minus 8 over 9. This is your quotient of this division. So y equals 4 over 3x minus 8 over 9 is the oblique asymptote line. Let's go to F. By considering the graph of y equals g of x minus f of x or otherwise, solve f of x less than g of x. We use this inequality get f of x minus g of x less than 0. So In the graphing calculator, we will put in f of x minus g of x. Go back to the graphing. Control left arrow. Then tab f5 of x equals f1 of x minus control divide 4x squared minus 1 over 3x plus 2. Enter. Go back to this tab. We need to unselect this f1 of x. This is the graph of f of x minus g of x. We are interested in this x-intercept so that we can draw the sign diagram. To solve this inequality, go to Menu, 6, 0. Menu again, go to 6, 0. 1.32. Let's draw this sign diagram. Now, we will use a calculator to check the sign for each interval, the test number. Let's use -2, -0.6, -0.55, 0, 1, 2. Let's go to calculator. Control menu, clear the history. Go to variable. f5 of x is our function. f of x minus g of x. f5 of -2. Enter. Positive. Go up. Enter. Change this into -0.6. Enter. Negative. Go up. Enter. -0.55. Enter. Positive. Go up again. Change this into 2. Enter. Negative. Now we can write down the sign for each interval. Positive, negative, positive, negative. We are looking for negative interval. So this is our solution. This is our solution. This is our solution. This is the solution for f of x less than g of x.